prove this, it's actually quite a nice short proof. You just have to get one concept first. You remember that this one is going to be based on the unit circle, but what we're actually going to do is we're going to increase the unit circle by a factor of b. So, we can multiply it by 2 or 10 or 1.5 or 0.5. So this point on the circle is now not going to be cos A sin A. It's going to be b times cos A, comma, b times sin A, because you've increased the unit circle by a factor of b. And I have my point 0, 0. And then I'm going to label my sides carefully. So if this is my angle A, this is my side A. If this is my angle B, this is my side B. And if this is my angle C, this is my side C. Which means that this point here is going to be C0, because, I'm going out a certain distance. That's my x coordinate. And because it's on the x-axis, my y-coordinate is 0. What I'm going to do now is, this is based on the distance formula. So just like the very first proof, that was based on the unit circle and based on the distance formula from coordinate geometry, this is also the same. It's based on the unit circle, that we have increased by a factor of b, and it's also based on coordinate geometry. So if we want the distance between this point and this point, it's a length a. So a is equal to x2 minus x1. So we're calling this x2, y2, this one x1, y1. So we have x2 minus x1 to be squared plus y2 minus y1 to be squared. And then you just work that out. And if we get as far as here, we see that we have b in common. We can take b squared in common. So we take b squared out in common, and we're left with cos squared a plus sin squared a, which, from your log tables, can be replaced by the number 1. So on the left, we have a squared. We've squared both sides here to get rid of the square root. A squared is equal to b squared times 1 plus c squared minus 2bc cos a.